Okay, I hear that it's now recording. So I guess I can start. Cool, 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 cool. Hey everyone, my name is LJ Miranda. Thanks again, Ryan, for the invite. And for today, I'll just be talking about labeling with large language models. First, I think Ryan gave me a really nice introduction, but I also want to talk about what I've been doing so far. I'm currently a pre-doc at AI2 here in Seattle. Previously, I was a machine learning engineer at Explosion AI. That's where I met Ryan. I've worked on several things. I've worked on Spacey, especially in terms of like the different NLP pipelines. I've worked specifically on the span categorization component, and I think we'll be touching upon that later. I've also worked on the Spacey LLM library, which involves like applying large language models to common NLP tasks. And finally, I've also worked on Prodigy, mostly for NLP annotation. Um, Let me know if you're hearing me properly. But my research interest right now revolves around many things, but they always involve annotation. It involves like if you're familiar with the large language models today, they were trained using RLHF or reinforcement learning for human feedback. And I'm working on ways on how to efficiently collect human feedback or collect preference data for to train these models. I'm also very interested in corpus annotation, and I also have like some side research projects that involves low resource data. So I'm working on some NLP pipelines for my native language and also working on some languages for multilinguality. So mostly focusing on Southeast Asian languages. Feel free to interrupt me if you have any questions, but this would be our agenda for today. So again, I want to talk about labeling LLMs, but I wanted to put it into context. I wanted to put it in the context of argument mining. So I will be motivating and introducing this task first, and then I will be showing three ways how we can apply large language models on the process of collecting argument mining data. And finally, just like some final thoughts, closing thoughts, and maybe some practical considerations. And hopefully after that, we'll have some more time for Q&A. So feel free to ask questions after that. Okay, so let's start. So argument mining, what is it about? Why do we need this? So, as you all know, one of the major problems of the 21st century is disinformation. What you see here in this slide are like different screenshots from a website called PolitiFact. So, PolitiFact is a website made by a team of journalists, and what they do is that they scour the internet and they manually tag each social media post or news story as fake news or not. So what's very interesting about what they do is that it's not just a binary like classification problem. It's not just fake news or not fake news. They actually have this scale of kind of like truthfulness. They call it truthometer, that talks about how truthful a website is. And that's very important, especially now, especially in our context and situation. Um, and the way fact checking works is very straightforward. First, you look for statements, and then you look for claims to fact check, and then you look for evidences presented for that claim, and then you verify these evidences from multiple sources. So maybe from a knowledge base like Wikipedia or from current news sources. And finally, you publish those fact-checking results. So in the context of PolitiFact, this would be in the form of those screenshots that you've seen from the previous slide. And as I've said, PolitiFact has this truthometer. It's very exciting. It's quite fun. It starts from true, and then you have like this final pants on fire, which is very, very fake or very, very false. It's not just PolitiFact though. There are other fact-checking organizations that do similar things. So, as you might have noticed, this is a very human process. You have to look into different statements, you have to manually tag them, you have to study them. And right now, there are like several efforts to automate this, and we call this as like automated fact checking. And the automated fact checking pipeline, as you would see on the right, isn't really much different from the human based pipeline. So, for example, in this case, you detect your claims, you try to verify evidences from multiple sources, and then you kind of like publish your fact checking results. So in this case, they're trying to automate each step of this human based pipeline by decomposing it into different NLP tasks. However, for today, we won't cover the whole gamut of automated fact checking. We'll only be focusing on claim detection. And also, I guess for today, I want to focus on like two key research questions. The first one is, given a text, what is the claim and what are the presented evidences, or what would be the premises? Second, we also want to know the stance of a particular claim on a given topic. So, for example, does it support, does it oppose, or is it just neutral to that given topic? And what we're going to do here is to approach these things, these questions, as NLP problems. So in this case, the first one, we could treat it as a span labeling problem. It's some of you might have already heard of NER, or named entity recognition. Span labeling is quite similar, but instead of looking for like named entities, which are sometimes usually proper nouns, you're looking for arbitrary slices of text. So these might be like noun phrases, chunks, or sometimes even whole sentences. You're just looking for arbitrary slices of text. Then for the second case, it seems easy. It's very straightforward text categorization, where you classify a text into one of n categories. So for our small example, it's just n equals 3. It's either we support, we oppose, or it's neutral to the given topic. Okay, all good so far? Okay, so before we dive deep into the annotation, I just want to kind of explain what these key questions are and just kind of like introduce some terms that we will be using later on. Um, the first is that we want to know the claim and premise for a given text. In fact, what we want to do in a span labeling problem is you want to highlight specifically where these are. So as a high level overview, claims and premises, they're like the two building blocks for making an argument. So a claim supported by a set of premises, you can consider that already as an argument. A claim is an assertion that can be falsified. They sometimes term this as a proposition or a statement. And the premise is like the reason that supports a claim or the evidences. And usually we use these things to imply a conclusion. So sometimes even if a premise kind of like supports a claim, it doesn't mean that it's factual. And that happens later on in the pipeline. And we don't really, for now, we don't really care about that because it's kind of, we're only focusing on identifying where the claim and where's the premise. So again, it's a highlighting problem. We're just highlighting text here. So yellow would be claim, green would be premise. And I think it's quite hard. I think these are these are very easy examples, but from a human annotator, this still requires a lot of like cognitive load. It takes some time to manually figure out which one's a claim and which one's a premise, but I'll give you the answers. So for example, for number one, the claim here would be smoking causes lung cancer, and then you have all these premises in green. And second, you have this first sentence, and then the premises would be in green. It's not always the case where the first sentence will always be the claim. It's not always the case. It's just so happened because these are like some of the easier examples. For quick question number two, it's a text categorization problem, and what we care about would be, does the claim support, oppose, or is just neutral to a given topic? So here we have an example. The topic is about smoking ban, and we just want to know if the texts below kind of like support, oppose, or neutral to that given topic. So I'll just give you the answers. The first one supports. The second one kind of like opposes. And the third one, it's just giving like some factual information. So we could say it's neutral. It does look straightforward because it's a text categorization problem, but the challenge here is that there's a nuance in these texts that might be hard, especially if they're kind of like way longer than the usual. All good so far? Okay, so for this whole introduction, what are we doing? We're working towards some very general conception of the problem and then framing it as very specific NLP tasks. So we start with a very broad problem, which is like automated fact checking. We focus on a specific step, which is claim detection. We keep this pattern. Here, we're treating it as an argument mining task until we arrive on like the things that we already know and love, like the whole NLP task that we know and love, which is span labeling, NER, text classification. And we'll be focusing on these two. Also, as an aside, finding the argument structure, it's not just about fake news. You can apply this across multiple domains. For example, in academic literature, you can use it to verify scientific claims. Number two, you can also use this to kind of annotate like legal arguments. So if you look at this matrix, if you look at the labels, if you can see it, they actually look like the NER IOB tags, right? So it's very related to what we're doing. And finally, you can also use this for education assessment, which is kind of like just checking the quality of different student essays. So these are just like examples on how you can use the idea of argument mining in the domain that you're interested in.
Hey, LJ, real quick. I was just before talking to a student about sentiment analysis. Would this same approach work for sentiment analysis, and how would you approach it?
Sure. The most common way you would approach sentiment analysis would be as a text categorization task, right? Like, would it be what does the sentiment of this particular text? But I think it's very interesting to look into like what are the kind of important words that highlight that particular sentiment, right? So you can highlight a particular phrase, or you can highlight a part. If it's a paragraph, you can highlight some particular sentences that say, oh, this one shows that it's against this particular topic, or this sentence shows that it doesn't like this particular product. I think that's very important. And we're going to talk about that in the second example, where we're not just looking at this as a very basic, oh, text categorization, give a text, give one output. It's more of we're trying to enhance our understanding of the text by like adding more meta information that allows us to understand it. So yeah, hopefully that answers the question.
Yeah, that was perfect. Thank you.
Okay. Now we go to the meat of this talk. So how can we use large language models on the annotation process? So if we want to build, or if we want to train NLP models, we need to collect a lot of data. This is especially true for domain-specific tasks like argument mining. When I say domain-specific, meaning it really requires a lot of expertise, or it does require a specific understanding of a particular field. So I want to present different ways of annotation using this graph. So on the far left, you have these like highly manual methods that kind of require a lot of human effort. And on the far right, you have like these automated methods that try to eliminate this costly process. And in the middle, you have like a good mix of both. So on the left, you might have things like expert and crowdsourced annotations. Here, you gather a group of annotators, you onboard them on your annotation task, and then you do like several rounds of annotation. You could argue that this is one of the more traditional ways of getting annotations, but turns out they've actually been powering a lot of the models, even that we've been using today. Even the large language models that we have today is quite dependent on these human annotated data. And feel free to ask me why, etc. later. It's very interesting. And on the far right, you have things like getting silver standard annotations. So the idea is that you partially annotate something from a base model, like a baseline model, and then you manually review. Sometimes you just annotate it and then you're done. For NER, you might have heard of WikiAnn. It is a name entity recognition dataset that covers several languages. But the catch is they didn't recruit any native speakers during that process. Instead, they use like a combination of like some neural-based methods and a knowledge-based like Wikipedia to automatically annotate the dataset. So the intuition there is like if you have annotations in English, if you have Wikipedia annotations in English, and then you translate it to, let's say, Tagalog or for my native language, as long as you know like the mapping between the syntax, then you can actually transfer the annotations to that other language. It doesn't always work well, but you know it's a good start if you want to train like a kind of a mid, kind of like a below average model to bootstrap your annotations. That would actually be a good start. And then in the middle, you have a good mix of both. Some folks, they do rule-based labeling functions. They ask a domain expert to define the rules, and then they automatically annotate that example. There's also active learning in Prodigy, where you have a base model that kind of like helps an annotator complete the annotation task by focusing only on like highly contentious or ambiguous examples. So if a model is like finding low confidence in their annotation, they can like pass it to a human verifier or a human annotator, which would be super nice. And finally, you have things like transfer learning, where you train a base model from a larger data set or a related task, and then you apply it for a more specific task. So perhaps for a sentiment analysis problem, you can use, let's say there is an existing pre-trained argument mining model. Maybe you can use that to bootstrap some of the annotations for that sentiment analysis, and then include that in your annotation UI, and then you help improve your annotation process. So for me, like LM and large language model annotation tends to be in this range. Um, it's slightly manual because you still need to write a prompt. It requires some domain expertise. But it's also automated because you harness a very large model to do the job, similar to transfer learning or silver standard annotation methods. So I guess I wanted to kind of show you like what makes LLM so powerful. I think there are two reasons, right? The first one is like web scale pre-training. When we say web scale, it's kind of they're training on almost a good chunk of the internet, right? And of course, we can talk about like how timely the data was. We can talk about the language coverage, but we cannot deny that large language models were trained on these very large data sets, and their capacity is quite high. And the second, I think, advantage for large language models would be their zero-shot capabilities. And what I'm trying to say here is that back then, if you want to use a text categorization model, you need to train something, or you need to find something that was already trained. And that model would only be limited to the labels or to the distribution that it has already seen. For large language models, you need to prompt it properly to give you the exact answer. It has the added bonus of flexibility, where that most kind of like static based models don't have. But what's very interesting here is that, as you will see later on, sometimes domain specific models are actually much better than LLMs. And I'm trying to get ahead of myself. But it's still very interesting that we can use that flexibility to bootstrap or jumpstart our annotations. So here's a Venn diagram. There are three ways I will be demonstrating, and each of them fall under this space. So the first one, bootstrapping. Here, what we're trying to do is we're taking advantage of the large corpora, or the large kind of like knowledge that LLMs were trained on, to get silver standard annotations, right? Um, Second is on directing the annotation by providing extra information. So we're not just asking the LLM to annotate for us, we're also asking it many things like, hey, can you highlight the claim and the premise for me so that I can better annotate this text? Or can you give out a reasoning as to why this is labeled as such? And those are here we're taking advantage of the flexibility of large language models. And I guess more on a very meta way, we can actually take advantage of both to reveal like the ambiguity in our annotation guidelines. I will be explaining this later, but I think it's a good way to look into how we can use LLMs to kind of investigate or analyze, were we actually annotating properly way before the age of LLMs? Are we actually writing our guidelines better? So we can talk about that later. Any questions so far? All good. Okay. Uh, most of the material most of the material was taken from my previous experiments and blog posts, so feel free to read them out. Okay, so number one, bootstrapping annotations in a human in the loop workflow. So, what I want you to do, I guess what I want to do is I want to give you a template of what's going to happen. For each bullet point, I'll be talking about a specific way on how we can use LLMs. So the first one is something related to the silver standard workflow. So we bootstrap our annotations, we pre-annotate it. And the idea here is that by pre-annotating the text or examples, human labelers won't need to label from scratch. They just need to verify and correct them. And I think the assumption here is that verifying or correcting has lower cognitive load than just like labeling from scratch, because you don't need to think right away. Right? You still need to think, but you don't need to kind of look into the text and everything. You already have like a kind of a preliminary answer written down for you, and you just need to verify it. Okay, to test this, I work on a portion of the UKP sentential argument mining corpus. So I want you to imagine like a data set with kind of like 25,000 plus sentences spread out over 8 controversial topics like minimum wage, cloning, etc. Um, and each sentence is labeled either as an argument that supports, opposes, or it's just neutral to a particular topic. So if you remember, this is kind of like the text categorization problem that I introduced earlier. And on your right, you'll see some examples for each label. So that's the setup. That's the experimental setup. And I have like some research questions, right? The first one is that are zero-shot LLM annotations competitive with manual annotation? So you might keep hearing like, what does like zero-shot mean? I'll show you later in terms of the prompt, but I guess the easy way to think about is that asking an LLM a question without much guidance, without like them giving out like a lot of examples. So just asking it a question, like an open-ended question, where and just specifying the format in which you want to receive the answer without any demos, without any examples, just zero shot. And there would later on you would see something like few shots, so kind of giving like few demonstrations, few examples. So what happens here? I guess like going back to number one, why am I asking that question? Because if LLM annotations aren't really competitive, then what's the point of bootstrapping, right? If I have to verify and correct all of them anyway. And the good thing is that if they are competitive with manual annotations, we can actually reach a scenario where we only need to verify a few like examples, correct a few examples, and that's good, right? And I guess ideally in the future there might be a scenario where um, a chunk of the annotation can be delegated to LLMs, but that's a deep rabbit hole that would be interesting. We will see. That's interesting. So I want to talk about the pipeline and how I'm going to answer this first question. So we have examples. When we think of examples, it's really here when I say examples, I just mean like a specific instance of that text, right? So we have a bunch of examples. We pass them to a prompt, and I'll be showing the prompt later. Passing the prompt to GPT 3.5. When I did this experiment, I think GPT 3.5 is still like the best performing model. So right now it's much different. And you get a bunch of predictions, right? But predictions from the large language model. So that's the first thing. So we have like pre-annotations. The second, and what we're going to do is we're going to compare this with our reference labels. So when I say reference, that would be the labels in the golden the golden test labels, or the ones from your test set. Basically, like what are the labels in the data set that you already have. And I guess I wanted to emphasize that if you're doing your own annotation projects, you won't have access to these reference labels, right? Because you don't have labels yet, etc. So it's going to be hard to compare. So what we're trying to do here is we're kind of assuming, what if we don't have these labels? What are we going to do, right? And then what I'm trying to do first is use a data set that already has labels so that it's easier to see how well we're performing. Hopefully that is quite clear. And then the second research question is more in terms of efficiency, like do I annotate faster with bootstrap annotations? And sure, there's definitely like bias here or something, but later on I will be citing some works that also arrive at like similar conclusions. And the setup here is that that's me, the human annotator. And then I have this all pre-filled, pre-annotated examples passed to Prodigy. And then I just verify and correct them with the best of my annotation abilities. And then I compare the annotation speed versus without these bootstrap annotations. So it's basically me comparing how well I do in terms of correcting and how well I do if I'm just annotating from scratch, right? And also, like, I just want to show you the prompt. Here is like the prompt template. Most of these templates that I will be showing, especially later on, were based from the Spacey LLM library. But I think they've more expanded right now. They're much better right now. These are like the early templates that I used. So some important parts of a prompt, you'd have like the task instruction that you tell or you explain the goal to a large language model. And then you have like the specific instance where you insert the text, and then you kind of like get an answer below. And then you try to parse that answer, using like simple scripts so that you get it. So, the first one, are zero shot LM annotations competitive with manual annotations? Turns out, yeah, they're good. So what I did here was to compare this LLM bootstrapping setup to a standard manual annotation process where I tried to manually label things. That would be the second column. And I also have like this third kind of like supervised baseline where I have like some train where I trained on some training and development data and just compare it on the test set. And again, we don't have access to this in the real world, like in the wild. We won't have access to this. It's just a matter of me comparing how well these large language models will perform compared to like the supervised baseline. So yeah, as it turns out, they're quite good. There are also like similar work and literature that we can definitely expand upon. So for example, they've been using large language models in an active learning fashion. And they use it for like linguistic tasks. For example, onto notes. So onto notes also contains some NER tags, and also Conal, which also contains some NER tags. The second one is the ANO-LM work. And then what they're trying to do is they look into how kind of like reliable GPT is compared to crowdsourced annotators. And there is definitely some comparability there that is quite interesting to see. Let me know if you have any questions. Okay. Okay. Second question, do I annotate faster with Bootstrap annotations? Turns out yes. And of course, here I kind of like timed myself annotating 1,000 examples in hours. And of course, it's not easy. Of course, like it's not just about, hey, you annotate faster, but are you annotating correctly? So I also compared like an F1 score of my annotations compared to just kind of labeling from scratch. And as it turns out, kind of like relying on large language models plus having some verification actually does help. There's definitely some improvement there. Again, there are similar works in literature. I think the co-annotate paper, the first bullet point, is actually one of my favorite papers. Last year, what they're trying to do is they're trying to distribute like the annotation tasks based on per annotator based on like some uncertainty estimate. So for example, if a particular instance is very hard, they will choose which annotator would annotate that, or which group of annotators would annotate that. I think someone's raising their hand.
Yeah, Chang, do you have a question?
Yeah, LJ, I think can you go back one slide? I feel like one thing that's very unintuitive to me was why the manual annotation has a lower F1 score than either of the machine learning model. And that's like very unintuitive. Could you what is going on here?
I think the sources of ambiguity here would be two things. Number one, it's just like random errors. It might just me like making mistakes in terms of my manual annotation that will be captured by the supervised model because they were trained on the training set, or they were trained on like the correct annotations. That's the first one. And I think the second one is really perhaps it's just noise. I'm having like troubles with some. I might have having some troubles with some instances or some examples, and that might have affected the score.
Gotcha. Thank you.
Okay. Okay. So any questions so far in the first third?
Hold on one sec, LJ. We have a question. Mike, do you want to? Yeah, you can ask it so directly.
It was on the slide you were just on. It was about the, I guess essentially the supervisor, like the
So can you go back to one more slide?
yes,
That one right there. Yeah.
The supervised baseline. So that's using a different LLM to kind of have a baseline for both the manual and the zero shot.
Sure. The supervised baseline is like training a Roberto model. So this is not using a large language. Think of this as like you're just training like pre LLMs. How would you train a text categorizer? That's it.
Yeah. Oh, just for context, so later on in class today, I'm going to show you guys on using that base model in Prodigy Train. So this is like the large or the transformer model, where that's how, so think about it in the same way that we've trained that NER model. That's again how you're developing your own supervised baseline, but it was trained again in that fashion. So, yep. Yeah, sorry, LJ. Yep.
Okay. The second way that we can use LLMs on the annotation process is by directing annotation, by providing extra information. So again, what we're trying to do this time is we're trying to be hopefully a bit more creative on how we use LLMs, more as an assistant rather than a static model that gives out labels. And here, it's more about like enriching the annotation experience. And back then, if you want to do the same thing, you need to like have a pre-trained model that does different things. But this time, because large language models are very flexible, they can be very task agnostic. You can ask it to do a text categorization task and it will do it. You can ask it to kind of explain its reasoning and it will give it something. But of course, you have to be careful on kind of like relying on all these on their outputs. So what we're trying to do is reduce that extra effort. We're adding more kind of like signals from the text with less effort. So two things that I will be doing. Two things that I will be demonstrating. The first one is like highlighting an argument's claim and premise in the annotation UI. And then the second is like including an LLM's reasoning as to why it selected a particular answer. So for the second one, it's more of like a demonstration of like this chain of thought reasoning that is a common way of prompting LLMs. And this would be like the final output that we want to see later on. So in the left, you have the claim and premise highlighted, and then you use this to kind of like figure out if they're kind of like for or against, or it's just neutral to the certain topic. And then the second one is you have a pre-annotation from the large language model, and then below that, you kind of have like the reason as to why they're doing something like that, or why they answered that way. Okay, so highlighting an argument's claim and premise in the annotation UI. The way I did it is that you have these examples, and then you pass it to a kind of like a span cat prompt, and then you pass it to a large language model. And what you obtain at the end would be the same set of examples, but with their claim and premises included into attached to each instance. And then, of course, you have the human annotator that tries to annotate them. And then you would arrive into something like this. So that's the first one. The span cat prompt is kind of different. Aside, instead of like just giving out an example, instead of just giving out one value, it tries to give you a different set here. You will have different values below that you need to kind of parse. And I think back then, it's kind of hard to kind of parse these answers because it might be different. Sometimes the premise might be lowercase or something like that. There are many ways this can go wrong. But I think right now, like large language models like GPT or Chat GPT has JSON formatters. So in some way, this difficulty has already been solved. But back then, it's really about like writing Python functions that tries to kind of find the premise and then do some text splitting, which is very, very involved and tedious. So these are like some examples, and I'm just looking into them. Yeah, so that's the first one. And then the second one is really more on including an LLM's reasoning as to why it selected a particular answer. Again, we start with a bunch of examples, then we put it into a chain of thought prompt, and I'll be talking about this later, and then sending it to a large language model. So here we get an output of examples plus kind of like their reasoning and kind of like their label. And as an annotator, what you want to do is that given this extra context, you want to decide, hey, does this actually make sense? Or do I just use like my own judgment? So again, at the end, it's always about like verifying the output of an LLM. You don't want to like use the output straight from the fire hose, basically. And the output would look like this. So I just want to talk about like chain of thought prompts. And what you're trying to do here is that you're trying to decompose a problem into small steps. Usually you would see this in like reasoning tasks like math or logical reasoning. So, sometimes they would prepend their prompt as like, hey, let's think step by step, or it's something like that. And for us, a good way to decompose a problem is to first identify the claims and premises. And based on those, we kind of like decide if this particular argument supports or opposes this topic, right? So this is the first one. So we have this, we kind of have like in the first paragraph, we have this like instruction that, hey, do this first, do this next, and then answer, and then finally answer in the following format. And I guess one way to do this is you provide a kind of like a one-shot example that tries to kind of give you that you're trying to provide a large language model how to respond. At least it's kind of like giving them the template of, hey, you should probably respond this way. And then you put the text right after. And these are like some of the examples from different instances, and I just put them there. Any questions so far before we proceed to the next? Okay, sounds good. So where were we right now? So the first one is more in bootstrapping. The second one is trying to direct this annotation by providing extra context. I think this one is more on we're kind of like looking back to our annotation tasks and kind of checking, hey, are we actually using our annotation guidelines correctly, or do we actually have like some consistency in interpretation when we're making or when we're writing our annotation guidelines? So this is more of like a meta study of how we're doing annotation. So I guess just to give you a brief intro of what annotation guidelines are, the idea is that you want to be kind of like as generic as possible, but as precise as necessary. What a very interesting requirement. But the goal is you wanted to reduce like ambiguity in terms of annotation. And later on, I want to talk about, perhaps we can talk a bit about ambiguity in terms of annotation. Those are very interesting topics. But for most of the linguistic tasks like name entity recognition or like parts of speech tagging for universal dependencies, your goal is to reduce ambiguity. Because the idea is that you have a function in mind and you just want to train a model and you just want to get a lot of data so that that model comes into fruition, right? It's really more about that. So right now, it's more about um, it's a one fun way to think about annotation guidelines is we can think about them as prompts, but for humans. And I guess one thing that we want to do is we try to pass them into large language models. Let's see what happens, right? Oops. So one perhaps like premise here is that most task instructions can be ambiguous and underspecified. And hopefully, like annotation guidelines, trying to be as precise as they want to be, hopefully that would be much better, right? And second, models are highly sensitive to prompts. Let's see what happens if we try to change these prompts and try to kind of make a matrix of annotation guideline per dataset, which is very interesting. I'll be showing later. So turns out different annotation guidelines have different definitions of what an argument is. So earlier in this talk, I was talking about, hey, what's an argument? It's a claim, it has a premise. But turns out it's not, it might be like the universal definition, but some papers would actually define an argument differently. Sometimes, as long as it has a claim, it's good. As long as some people would be much stricter. There should be a claim, there should be a premise in order for it to be considered an argument. Um, we don't know if these things are intentional or not. Usually, these are just artifacts of how their research problem was formulated, or maybe that's like how their data was initially collected, and we have nothing else to do about it. For the purpose of this experiment, we just want to make things very simple. The final task is really to classify if a sentence is an argument or not, like very very straightforward binary classification problem. In the table below, you would see different papers, and then you would see some of their labels. and they have like different ways of how they define an argument, right? So some papers they need to ensure that the premise kind of like supports the claim, etc., etc. Some papers are fine as long as they have a claim. So that's very interesting to see. Mhm. So the initial setup is the same. We have examples, then we include it into a prompt, pass it to an LLM, and make some predictions. However, our prompt this time is different. Um, so we have the task instruction, which is what we want the LLM to do. But at the same time, we also want to kind of attach the annotation guideline. And then we put the question at the end, like, is there an argument or not? Of course, back then there was a challenge, right? How can we fit very long annotation guidelines into limited context? Right now, most models, I think, have longer context. So some of them are like 32K tokens, which I think can fit a very long annotation guideline. But back then, you have to find ways on how to kind of put them into like your single prompt. So I'll be showing one way to do it in a while. So what I did back then is I chunk the annotation guideline, and then I tried to refine the prompt's answer. So some of you might be familiar with like LangChain. So they call it like the refine step. So that was like the popular open source library for prompting back then. So what we do is we split the document into arbitrary chunks that fit an LLM's context length, and then um, we write the seed prompt, and then we obtain like some certain level of prediction, and then we write a refined prompt, and then we get another prediction. So it's kind of like, first, given page one, what is it? So here's the question. Here's some context, like the first page of the annotation guideline. What do you think is the answer? So you have an initial answer, which might be true, which might be correct or not. And then you try to flip the page and show, hey, here's the next context. Would you change your answer or not? So it's mostly kind of like refining that answer. And of course, I would say this is not a very strong way of using, of kind of like refining answers. If you can always fit them into into a longer context like large language model, then I think that's might be the better option. What? Okay. And then you obtain like the prediction so far. So it's really about just refining the output. So here's what the seed prompt look like. You start with the initial context, and then you say, given the context information and no prior knowledge, you try to classify the text. And then afterwards, you keep showing like a refined prompt where here's the original answer, here's the original question, here was the existing answer, here's some new context, and then you can refine the original answer, or just return your answer previously. So what I'm trying to do here is that we're kind of like comparing the performance of our annotation guideline plus LM predictions to the reference annotations. So how do you interpret this graph, right? So we have like three things. Each of these papers, they have their own annotation guidelines, which is very interesting. So they have their own annotation guidelines, and then I tried to use them I tried to use them on the prompt, and I tried to compare it with like their golden like answers. Hopefully that makes sense. So basically what I'm trying to do is, okay, what if I prompt the annotation guideline to an LLM versus just comparing it to the actual like labels that they already had? And I think I would say that this is more of like a negative result, because as it turns out, like even if you include the whole annotation guidelines, we're just getting like very middling results. Like the language model still cannot identify correctly what the answer is or what the label is, even if you provide the whole context of the guideline. Hope that makes sense. I guess the key takeaway here. Oh, hey, someone asked a question.
Sorry, it's me again.
Sure.
Just want to, because I was reading this, I want to make sure I understand what you meant is if I use my annotation guideline and then use it as context to add it to my LLM label LLM annotation process and
Right.
compare it with using LLM to do zero shot or like very basic prompt, then by middling you mean that like their annotation guideline actually made LLM do worse?
That's the surprising result. Yeah. And I think that um my kind of intuition here is that um annotation guidelines were probably written for humans, I think. And I think humans are have like much better way of processing have a better way of I would say they have a better kind of internal knowledge of how they approach these guidelines compared to an LLM. And as it turns out, like using simpler prompts might actually be much better for large language models.
Thank you.
So yeah, I think that's what's surprising here. And I think that really shows that, hey, maybe like human annotation can actually kind of like wade more in terms of ambiguity and in terms of these longer contexts more than large language models. And maybe large language models, they work better on like more simplified prompts. And I think like getting more precise might actually do worse. So that's very interesting. And maybe it's not because and one thing that we still don't know is if it's actually related to ambiguity, right? Maybe it's just like some random tokens that makes the LLM much more confused. So it's a very interesting topic as well. Oops. Another thing that I did, which is very interesting, is that what if I used another annotation guideline for a different data set? It's just very interesting, right? So all of these three papers have like different annotation guidelines, and I just want to try to use one over the other. And it's very interesting. Some guidelines are transferable, and I think the takeaway here is that sometimes the framing of the task is always important. It's still hard to kind of get some good insights from here, but it's just more of if you're using I think here I was thinking about like prompt transferability. Like sometimes prompts that work on one task as can actually like work on the other. And that might be useful for like some of the annotation tasks that you're going to do in the future, right? So instead of like writing one prompt for every annotation task, maybe it's possible to just use a single prompt and then distribute that to different tasks. Hope that makes sense. Okay. Final thoughts, some practical considerations. I think there are three C's to consider when you're labeling with LLMs, right? The first one is the context. What is the purpose of the annotation project? Is it to capture correct responses? I think you would see this mostly on linguistic tasks like parts of speech tagging, dependency parsing, or is it a matter of like capturing the whole gamut of human judgment, right? For example, hate speech detection, social biases, in which different annotators might have different answers. Um, I think for me, large language models, they're quite good in letter A, right? If you have a function in mind and you just want to collect data and you want to just train a model that would give you the correct and reliable answer, I think bootstrapping with large language models is still a good way to do that. Second, I've seen some works that is kind of like asking an LLM about its confidence. It's very hard to do, and I think it's always unreliable because it's kind of these are like surface level text, and it might always be it's not always transferable to actual confidence. And I think one good way to do this is to go a bit deeper and look at the output logits or the model confidence. Basically, you wanted to look at the final layer of the large language model. And you can do this with like other libraries right now. There are also other proxy for confidence. So one way is using rank classification. And third is what is your annotation budget? I think this might change as we go along. Open source models are free but require GPU upkeep. But recently, we've been seeing a lot of open source LLMs that can run in an M2 Mac, etc. So they're getting cheaper and cheaper. There's also the question of like crowdsourcing versus LLM bootstrapping. I think crowdsourcing is still good because you're getting like the diversity of human judgment, but maybe there's also an interest in like bootstrapping with LLMs, right? So it really depends on what's the budget, right? So it really depends. And some final thoughts, like in what type of annotation can we use LLMs? Again, there are questions you need to ask yourself, like what does the label supposed to reflect? And number two, like what do you want to use the data for? I think there are two ways to think about annotation. There's the prescriptive way of annotation, where is it supposed to reflect like a prescribed idea you have in your head, right? So again, I have been alluding to this earlier. It's about if you have a function in your head and you just want to train a model and you just want to collect reliable data to train a model that would reliably give these outputs. Um, that's where LLM might actually be good at. And second, is it more of like descriptive? You just want to capture the diversity of human judgment. And this is very useful recently in terms of capturing human preferences where there's no correct answer. The goal is not really to get like a gold set of labels. And sometimes in annotation, you're computing for an inter-annotator agreement, and and it's not about improving this agreement. It's really about understanding, oh, why do these annotators disagree? Which examples are they disagreeing with? And what does that tell us? So it's a different way of approaching these metrics. I think large language models, um, they're not, I guess if you're looking for diversity of human judgment, I think using large language models may not always be the best way to approach this. But I'm seeing some papers, and what they're doing is that they're comparing different annotator groups, meaning crowdsourced workers, domain experts, and GPT-4, and seeing how they differ in approaching several tasks, like hate speech detection or looking at social biases. And that's also like a good research question to think about, right? Like, how do they differ in terms of thinking or in terms of like approaching a particular question. And I guess like this is the final slide, and this is like what I want you to take away. So these three ways of like using large language models for labeling, they take advantage of these two LLM capabilities, right? The first one is web scale pre-training, and then the second one is really having these zero-shot capabilities that allows them more flexibility. And each of them fall under each. And of course, there are still many ways to do that in this Venn diagram, and hopefully you can discover them as you go on with your annotation projects. So that's the last slide. Thank you for listening. You can find these slides by scanning the QR code. If you have any questions, feel free to ask me or reach out. No worries.